This video is about manipulating mass exponent expressions, so you should already be able to construct them and solve them, but now we want to know how can we manipulate them in case the recipe doubles or triples or halves or reverses. So the question of the video is that same phosgene gas that was used in World War II with that reaction had a Kc value of 1.2 times 10 to the minus third, meaning that it was really reactant heavy. It doesn't really make a lot of phosgene at this temperature when we use 1 molar. Will a reverse reaction occur with better results? And what if we doubled the concentrations? Would that help at all? So maybe those are some of the things that people thought about the phosgene gas. We'll come back to that. So first, some rules. If you reverse the equation, you must take the reciprocal of the equilibrium constant. So in other words, if you had originally had N2O4 makes NO2, the Kc would have been NO2 squared, because there's 2 of them, divided by N2O4, and they gave you this value. And if I reverse it right in the other order, or just read it backwards, then that means that N2O4 will be the numerator now, and the NO2 that was squared will be the denominator now. So rather than actually finding numbers and plugging them in again, we could just inverse or reciprocal the 0.212 that was given, and we'll get the new Kc. So again, because the expressions are inverses from each other, we can just inverse the value as well. If you multiply an equation by any number, you must raise the equilibrium constant to that number. So again, if we use the same reaction we did before, it would be products over reactants, so NO2 squared divided by N2O4, and this is the value we saw before. But if I doubled them, so doubled the recipe, then that means I have to actually raise into the second power of what they used to be, because now the coefficient is 4, and the coefficient for the reactants was 2. So instead of actually plugging numbers in again, which I obviously don't have, I can just take the original Kc and square it because I doubled the recipe. So when you double a recipe, you actually wind up raising it to that power, the Kc to that power, so squaring it. What would happen if I tripled the recipe? Well, then I would cube the Kc, right? Or if I halved the recipe, well, then I raise it to the half power, which maybe you know is square root. So again, raising it to the power is really important. Last, if 2 equations are combined, you must multiply their KEQs, and this one's a little less intuitive at first. So the first reaction I have here is hydrogen ions times fluoride makes HF, and its K value is 2, meaning it's product heavy, and it's product over reactants, right? So HF times over H ions and F ions. The second equation I have is hydrofluoric acid reacted with sodium ions and made sodium fluoride and hydrogen ions. It was even more product heavy, and this was its K value. So products of NAF and hydrogen ions divided by the reactants of hydrofluoric acid and sodium ions. So if I wanted to combine these equations, what I would do is cancel out the H ions and the HF ions, but therefore I can actually cancel them out if I multiply these 2 equations, right? I'd also cancel out the HF with the HF here. But that would also cancel if I multiply these 2, they would cancel out here, right? So notice that I multiplied them, which means now I can combine these equations. So fluoride and sodium are reactants, sodium fluoride was the products, and that means I can combine them by multiplying, right? And if I combine them, it would be NAF, which is the numerator left over, divided by Na and F, which are the denominators left over. So therefore, if I'm multiplying the expression, I should actually multiply the values. So rather than actually knowing the concentrations, I can just do 2 times 3, which is 6. So combining or adding reactions really means we'll be multiplying their Ks. So back to the question in the video. If the phosgene gas is highly toxic, how did they make more phosgene? Did they reverse the reaction? Well, if we reverse the reaction, it would be 1 over K C that was given because I'm inversing it. And so I would rewrite them out of order. So that means I'm going to inverse the value that was given. And that value came out to be 833. The reverse does happen more, but if I'm reversing it, I'm actually using the phosgene that's there to make Cl2 and CO. So that wouldn't actually make more phosgene, but it does happen more often. The reverse happens more often than the forward. But how about doubling the effect of the concentration? So let's take our original K values. Oh, and I showed here that it would be 29 molar, I guess, and they would be really concentrated if I went in that order. So if I double their values, that merely means I'm going to raise everything to the square value, right? That's what we learned. So if I plug the numbers in, K squared, I'll get even smaller number. So it means if I put even more COs and Cl2s in for each, and present CO, Cl2, I put 2s in for everything, then it would happen even less. Ugh. So in this case, doubling everything does not help because it's going to actually reverse the reaction because you're going to have too many products now. So we're going to have to think of some other ways where Le Chatelier, if you remember from last year, is going to come into play. At this point, You should be able to manipulate and combine mass action expressions.